Hi everyone, and today we are going to solve this LeetCode daily challenge. Find eventual save states. So we are given a directed graph of n nodes, and we are given the adjacency list. Okay, here it is called graph. So from ith node to which nodes you can go to, like what nodes are adjacent to the ith node. So if you see this example, like zeroth this is the adjacency list for zeroth node. So the node 1 and 2 are adjacent to zeroth node. Node 2 and 3 are adjacent to node 1. Node 5 is adjacent to node 2. So this is what this graph represents. They are saying that the nodes, like kind of leaf nodes, here we call them terminal nodes, have no outgoing edges. Like 6 has no edge which is going out of 6, and 5 also have no such edge. So 5 and 6 are terminal nodes here. They say a node is safe if every possible path starting from that node leads to a terminal node. Like if you talk about node 2, you can see from 2 we can go to 5, and 5 is a terminal node. Similarly, in case of 4 as well, if we go from 4, we could go to 5, and 5 is a terminal node. For 0, you cannot say that. From 0, you can go to 1, from 1, you can go to 2, and from 2, you can go to 5. So you might be thinking 0 is also a safe node, but no, there is some other path. Like from 0 you can go to 1, from 1 you can go to 3, and from 3 you can go to 0 again. So that is why 0 is in the safe node. So what we want is, we will pick a node and we will go as deep as possible. Like if we reach a terminal node, then the node which we picked, for example 0, it will be a safe node. And if we reach a safe node, then we can just say that yes, there is a possibility that this node might be safe. Okay, so what I'm saying is, suppose we have a source node S, and we want to decide if S is a safe node or not. So we will, starting from S, we will go deep down the graph, and if we encounter a terminal node, then we can say that S is a safe node. And if we encounter a safe node, we can say that S can be a safe node. We cannot say in surety, but it can be. If all the paths which are leading from S to other nodes, uh, to the other nodes, and those nodes are safe, then we can say that S is also safe node. So we can use DFS for this problem. We will apply DFS on each node, and we will check like if if this node is safe or not. And like if you reach a terminal node, then you can confirm that S is a safe node. But what about the other case? In that case, we will usually check if there is a cycle. Like if I'm going in such a way, like first I started with 0, then I go to 1, then I go to 2, and from 2 I went back to 1 again. So there is a cycle. So I could say that 0 can never be a safe node, because yes, it will never lead to a terminal node. So you can write a DFS solution for this. So I will say like I have three states of a node. Like we haven't entered the node, or we have entered the node but we haven't exited it, and the third state will be that we have exited the node. So I will color these three cases. So how I'm going to do that? uh, I'll have some constant, and this constant will be max n. The maximum number of nodes can be 10 to the power 4, I guess. Yes, max 10 to the power 4. So I'm using something like this, and I could say color. Color is max n. and color of I will tell me the color of ith node. If the color is 0, this means that we haven't entered this node, and if its color is 1, then it means that we have entered the node but we haven't exited it. And the if color is equal to 2, then we can say that we have exited this node. Also we can say that is safe. This will tell us if the ith node is a safe node or not. Okay, like if we encounter a safe node, then we can say that S can probably be a safe node as well. You can try the TFS function. Boolean will the return type is Boolean because it will return that if node U, which we are, like suppose we can say source, if source node is safe, then we will return true. If the source node is not safe, then we will return false. Okay, so you can also modify this function to say is not safe. So when you enter the DFS, you can say that we have entered this node src, and then you will traverse all its adjacent nodes. And you can take graph as well. Now you can say, like, if the color of 2 node is equal to 0, it means that we haven't entered this 2 node yet. So we want to enter this node. So we will enter this node. You can also take a variable to say this if src is safe. Is src safe? And we can initialize to true. Yes, right now it is safe, we are assuming. And if 2 is also safe, the node which is the node to which it is going to, if that is also safe, then it should remain safe as well. Something like this. Else 2 is equal to 1. See, this is a very good case. Like we are coming from src and we are going to 2. So this 2 node, if this else if represents that src is also visited and 2 is also visited, but from 2 we haven't exited yet. So this can be only be possible if 2 is an ancestor of src, right? Think about it. You came to src, then you go to 2, and 2 is currently being visited. This means this, that we have visited 2 but we haven't exited it. It means that 2 must be visited before src, so it must be an ancestor. So in graph terminology we call such type of edges back edges. So we found a back edge here. So we can say if there is a cycle, then this node src can never be a safe node. You can just say false. Else 2 is already explored and exited. So we just want to know if we were able to explore the node 2, then we just want to know that if it is safe or not. So is safe 2. After doing all of this, you can color the graph src to 2. This has been explored now, and you can return is src safe. Okay, so I'm sorry, you can update this as well. Finally, you can run dfs. and if not color UI, then and then you can also have a vector answer. You can traverse all the nodes and check if is safe I, then answer dot pushback I, and finally you can return the answer. Yeah. So the problem is basically to find the cycles or back edges, you could say. So the time complexity of this solution would be O of V plus E, number of vertices plus number of edges, because we are just using DFS here. So thank you for watching this video. I hope you like it, and please hit the subscribe button and also hit the bell icon to receive any notifications. Thank you.